So hey guys, welcome back to another video and hope you're staying safe and staying home. And today we'll be discussing about another scheduling algorithm which is called the priority scheduling algorithm. So from the name you can guess that this algorithm basically focuses on the priority of a process. So this algorithm is always preemptive, meaning whenever you have a high priority process, we would like have a context switch. So let's say you have two processes and plus 1 and 2, and suddenly you're clicking on 2 continuously. So you want process 2 to come up and work. So your OS would basically decide that this process has now a higher priority. That's why I said that the priority of the process is determined by that OS. So the more you click on a process, the higher the priority gets, right? And the lower how is the value defined? So this is a process having priority of, let's say, 1, and this is a process having a priority of, let's say, 3. So 1 being the lower value would have the higher priority, and this would have a lower priority, and we would compare these processes based on this priority value, right? So let's just look into the problem here, which is this one. And similar to all the other scheduling algorithms, we would have a table where we would have the burst time, the arrival time, and in this case we have the priority, and we have to find the waiting time and the turnaround time. So let's just try to solve all of this, and we would understand as we go on. So P1, the process that comes at the arrival time of 0. So at the 0th second we have P1, which has a burst time of 10 seconds, and at the 0th second, so P1 arrives and it has a priority of 3 among all the other processes. So in this case we do not have any other processes to like compare to, right? So P1 being already the highest priority process here. So P1 works for 2 seconds. So P1 has 8 seconds left. Okay, so on the second we have a process P2, and P2 has a higher priority than P1. So P1 had 3 and P2 has 1. So definitely P2 would get the CPU, right? So P2 comes in and P2 has a burst time of 1 second. So at the 3 second, P2 doesn't have anything left to do, right? And on the 3rd second we have another process P3, which has a priority of 4. However, so P2 is done. However, P1 had a lower, like higher priority, a lower value, right? So P1 would continue its work till the 5th second. So in the 5th second, so P1 would be able to work for 2 more seconds, which would make it 6 seconds of remaining time. Now at the 5th second we see that we have another process called P4, which has a priority of 5. Now among P1, P3, so P1, P3 and P4, we have P1 with the lowest priority, then we have P3, then we have P4. So P1 would be able to continue for 1 more second. So at the 6th second, so P1 would have a remaining of 5. So at the 6th second we have another process, which is P5. Now among P1, P2, P3 and not P2, so P4 and P5, all of them, which one is like the highest priority? Of course P5, because it has the value of 2. So P5 being the lowest priority here among all the process, and there is no process coming in anymore, right? So P5 would work for 5 seconds, which means we would go up to 11 seconds, and P5 wouldn't have anything remaining. So we are done with P5, right? So among P1, P3 and P4, which one is the smallest? Of course P1, right? P1 had 5 seconds left, so P1 would work for 5 seconds, and making P1 has nothing remaining. So at the 16th second we are done with P1. now we have only P3 and P4. So among P3 and P4, P3 is the smallest, and we haven't touched P3 either, so P3 would work, and would work for 2 seconds because its burst time is 2. So at the 18th second, P3 wouldn't have anything left to do, so it would be completely done. And P4, so it has a burst time of 1 second, so P4 would work for 1 second. 19 seconds, P4 wouldn't have anything left, and at the 19th second all the processes would be completed. Now let's try to calculate the waiting time and turnaround time for each process. So P1 comes at the 0th second and P1 leaves at the 16th second, so the turnaround time is 16 seconds. However, what's the waiting time? So we always remember, so turnaround minus the burst time would be the waiting time. So for this case, 16 minus, we have 10, so P1 waited for 6 seconds. P2 came at the 2nd second and left the RAM at the 3rd second, so the turnaround time is 1 second. It's basically its burst time, and it didn't have to wait for anything, so 0 seconds. P3 came at the 3rd second. P3 left at the 18th second, so 18 minus 3, that's 15 seconds. So the turnaround time for P3 is 15 seconds, and P3 had a burst time of 3, so it had to wait for 13 seconds. P4, now P4 arrived at the 5th second, right, and ended at the 19th second, so 19 minus the 5, which is 14 seconds. So P4's turnaround time is 14 seconds, and it had a burst time of 1, so it had to wait for a whopping 13 seconds. Because P4, it came here, however it got the CPU here, right? So 18 minus 5, that would be 13 seconds. So see, the waiting time is 13 seconds. And finally for P5 came at the 6th second and left at the 11th second, right? So 11 minus 6 is basically its burst time, so turnaround time 5 seconds. It didn't have to wait for anything, so the moment it came into the RAM, it got the CPU because of its priority, so it didn't have to wait for anything. So this is basically the priority scheduling algorithm, and this is a simulation of it. This is pretty easy. You just have to keep in mind how much remaining time you have and what's the priority of that corresponding process that comes into, and the processes that you already have, right? So hope you guys did understand this video, and if you have any comments or suggestions, feel free to comment down below. Thank you.